Exponential behavior. Exponential functions do not have a constant rate of change. If they did, they would be graphed as a line on a coordinate plane, right? That way or that way. But they're graphed as a curve, so they don't have a constant rate of change, but they do have constant ratios. And what does that mean? That means that the x-axis are equally spaced out, right? So how to determine exponential behavior, how to determine if a function is exponential? Well, we can check these three criteria. First, check if the x values are equally spaced out and determine the change in x. Right? So that might mean that the x's are spaced out by 1, right? So it'd be 0, 1, 2, 3, 4, 5. In this example down here, you can see the x values are evenly spaced out, right? This separated by 3, right? 0 to 3 is 3, 3 to 6 is 3, 6 to 9 is 3. These are evenly spaced out. Next, we're checking if the y values are equally spaced. If they are equally spaced, then the function is linear, and we have a line. All right, we have a line. But if not, then it's nonlinear, and it could be exponential. So if we're looking for exponential behavior, we want the y values to not be equally spaced. Okay. Next, we're going to check if there's a constant multiplying factor that will take you from y value to successive y value. If there's a constant multiplying factor, then the function is exponential. Alright, so it has to pass check 1, it has to fail check 2, and after failing check 2, it has to pass check 3. Right? And then we could say that it's exponential. So let's go ahead and take a look here. We have this set of x values and this set of y values. Right? And the first check is, are the x values equally spaced? And we already talked about this. The x values are equally spaced. Right? So we can say that for number 1, yes, they are equally spaced. Right? We could put a 3 in there. Number 2, are the y values equally spaced? And for number 2, I'm going to say yes, they are equally spaced. And they're spaced by the value of 4. Right? And so if the y values are equally spaced and the function is linear and it is not exponential, right? So we want to determine here whether it displays exponential behavior. Say no exponential behavior, right? Function is linear. And why? Because the y values are evenly spaced. The y values are evenly spaced. Alright, let's go ahead and take a look at example number 6 now. First check is, are the x values evenly spaced? And if we look at them, yes, they're separated by a value of 10. So say yes, comma, x values are separated by 10. Okay. Next, we're going to check are the y values evenly spaced? And we can see here it's 0.6 separates the first two y values. Then here's 0.12. Then here it's, right? So we could say here no, right? Y values are not evenly spaced. Alright, so now we want to look and see, is there a factor that we can multiply this y value by to get to this y value, and we can multiply it by the same factor to get to the next y value. And if we look at it closely, we could see we multiply 1 by 0.4 to get 0.4. Then if we multiply 0.4 by 0.4, we'll get 0.16. If we multiply 0.16 by 0.4, we'll get 0.064. So we're going to say here, yes, there is exponential behavior. And why? Because there is a common factor between y values. Put a box around that.